Okay, so as I said, we do have the big quiz today, and our warm-up is going over that. So if you are absent, I would recommend paying attention to what we're doing here so you can see what you missed. It's actually not that bad. If you're still struggling with this, make sure you're asking questions now. These are the exact type of problems you'll be having on your quiz. So if you don't understand it, ask questions now so you know how to do it for your quiz. Thank you. Okay. Also, I'll try to keep reminding you guys of this. We have Math Honor Society tutors that will work with you one-on-one. I know some of you have already taken advantage of that. They're here Tuesday mornings before school from 7:15 to 8. You can come in at any time. And Thursdays after school. So like today after school, they're here until 4 o'clock. There's like 10 different students that are just in there waiting to help you. So come take advantage of that. Also, the Herndon United Methodist Church across the street.
Church?
Yeah.
So you're going to go to church for math?
They have tutors to help out on Wednesday nights from 7 to 8. So you can, of course, ask us questions, but no, there's tutors to help you out Tuesday mornings, Wednesday night at 7 p.m. at the church, as well as Thursdays after school here.
7 p.m. to what time?
8 p.m.
Only 1 hour.
Yeah, but that's an hour you can get there.
So you're going to walk for like...
Okay, so let's take a look at our warm-up. The first one should be extremely easy. Slope is 1/2 and y-intercept is 0,3. Remember, for all of these, we use our equation y equals mx plus b. That's what we're starting with every single time. We need to take our values that we have and put them in. So number 1, slope. Which letter does that represent?
M.
Good. So m is 1/2. And what does y-intercept represent? B. So b is 3. Alright, so my equation is y equals 1/2 x plus 3. Instead of m, I put in 1/2. Instead of b, I put in 3. That's it. We're done.
Easy.
Easy. Questions on that first one?
No.
Wait.
Yes. Remember also that your y-intercept, if you ever have a point that has 0 for x, whatever other number comes next is your y-intercept. So anytime x is 0, whatever your y value is, that's your y-intercept. Alright, so number 2, they gave us the slope, which is m, and they gave us a point. Now, is this my y-intercept?
No.
No, because x is not 0. So this is my x value and y value. So all I have to do is take these and put them into my equation. So y equals mx plus b. Let's take what we have and put it in. What is my y value?
8.
What is my m? And we're multiplying here. What is my x value?
2.
Plus b. So now I solve. 8 equals 4 times 2 is 8 plus b. Subtract 8. And I get 0 equals b. So when I write my equation, I have y equals, my slope is 4, x plus b, so we could do plus 0, but remember we don't need that because when you add 0, it's just the number itself. So it's just y equals 4x. That's what I'm saying. Alright, other questions so far? Okay.
Don't do that. I don't want to do that. What are you doing? I'm trying to, there.
Okay, so number 3. They gave us 2 points. Now this is what you had to do on your homework last night. They gave us 2 points, so we need to find our slope. Every single time we're trying to find our slope and our y-intercept. So we need to first find those. Very good. My formula for slope is y2 minus y1 over x2 minus x1. So that's all I have to do. Make sure you go in the same direction. Subtract your y's, 8 minus 10, and subtract your x's, 3 minus 5. Notice I went in the same direction both times. Okay, now we simplify that. 8 minus 10 is negative 2. 3 minus 5, and what's a negative 2 divided by negative 2? Good, 1. Make sure you're careful if you have a negative within your point here. So let's say, for example, I had the point -1, -2, and 3, 4. When I subtract these, I have 4 minus a -2, and 3 minus a -1. Make sure you're careful that you don't lose your negatives. Minus a negative becomes plus a positive. Alright, so be careful with that. Alright, so going back to number 3 here. So I have my slope is 1. Now we need to find the b value. I need to find my y-intercept. So again, I take my equation, y equals mx plus b, and I take what I have and put it in.
Move this down some more.
Okay, so in order to find my y and x, I just pick one of my points. I'm just going to pick the first one. Alright, so from here, what is my y value? 10. My m is what we just found, 1. X is 5 plus b. So we get 10 equals 5 plus b. Subtract 5, and I get 5 as b. So I now have my y-intercept. I have my slope, so I put into my equation. Leave y and x as themselves. So y equals my slope, which is 1, x plus b, which is 5. And again, we don't have to have that 1 there, so just y equals x plus 5. Exactly. Exactly. Exactly right. Alright, questions on number 3. That's what you had to do on your homework last night. So we have our 2 points. We find slope, and then we put in our x and y value, as well as slope, to solve for b, and make our equation. Okay, number 4 and 5 are a couple special cases. Oops. I lost my 5 in there. Alright, number 4. It says a line parallel to y equals 4x plus 10 and goes to the point 2, 16. Alright, when a line is parallel, what is true about our equation? Perpendicular is 90-degree angles, you're right. What do we know, Jimmy Johnson?
The what's it called, the slope is the same.
Yes, the slope is the same. Good. So when a line is parallel, that means my slopes are the same. So I take my slope from here, and that's going to be my slope for my new equation. Alright? Now, they did not give me my y-intercept, so here's my x value, here's my y value. Same thing as before. Y equals mx plus b. Take what I have and put it in. I know my slope has to be the same. So my y value is 16. My slope is 4. My x value is 2. And my b value they did not give me. The only thing we take from the original equation is the slope. Nothing else. Ignore all of this. We only want our slope. Alright, and then we solve here. 16 equals 8 plus b. Subtract 8. And I get b is 8. So now I have my y-intercept. I have my slope. So I compile it together. Y equals mx plus b. 4x plus b. So every single time we're using y equals mx plus b, we're trying to find slope and trying to find b. Then we put that together. Alright, questions so far?
I don't get it.
You don't get this one? Okay. Did you understand how we got our slopes the same?
No.
So anytime it says a line is parallel, that means my slope is the same. So anytime it says parallel, I immediately take my slope from there and know that's going to be my slope for my new equation. Then it's just like before. Up here it said we had a slope and we had a point. Well, that's what we now have down here. We have a slope and we have a point. So we take that information, put it in my equation. Here's my equation. I get y for my ordered pair. I get slope from the equation I just had, if it's parallel. And I get x for my ordered pair. That leaves me with b, which I solved for. So then I have slope, I have b, and I put it into my equation. Do you understand how we got b?
16 divided by 4 or what?
So what we did here is y is 16. Because here, y. M is 4, because my slopes are the same. So it's 4. Then x is 2, because we get that from my ordered pairs. And then I just put that all together. So 4 times 2 is 8. 16, 16. And b is b. Then I subtracted 8. 16 minus 8 is 8. 8 minus 8 is 0. I get 8 is b. Does that make sense?
Yeah.
Okay, so then I have my b. I have my slope. So I put that into my equation. Slope b. Okay, and then finally, number 5. What does it mean to be perpendicular, Louise?
Same slope.
No. Opposite.
What'd you say about 90 degrees?
90.
Yes, perpendicular means they come together at a right angle, 90 degrees. And so if it's perpendicular, what does that mean for my slopes?
They're opposite.
They're opposite and something else. Starts with an R. Good, opposite and reciprocal. So that means flip and switch. Alright? So parallel, it stays the same. Maybe something you can use to help you out is you see in parallel, you have two L's next to each other. It's the same thing, LL, so same slope. Perpendicular, we have opposite and reciprocal. So flip and switch. Okay, so it says it's perpendicular to my line here. What is my slope of this line? Right. Yeah, so it's my slope is -2 right now. So my new slope is going to be positive, and then we have to flip it. So 2 over 1, how does that get flipped?
1 over 2.
Good. So a positive 1 over 2. So again, we make it positive, that's the opposite, and then we flip it upside down. So we switch the sign and flip it. So 2 is the same thing as 2 over 1. So when we flip this, then I get 1 over 1. Alright, so I now have my slope, and they gave me a point, x and y. So exact same thing we did before. Y equals mx plus b. What is my y value?
13.
13. And Luis, what's my slope? Good. And what is my x value? 10. Plus b. Anybody know what 1/2 times 10 is? Good. 5. And when I subtract 5, good. We get b is 8. 8 seems to be the number for today.
Yeah.
That's my lucky number.
Alright, so now I have my slope, I have my y-intercept. So let's put that in my equation. Y equals mx plus b. So let's replace my m and b. 1/2 x plus b. That's my answer. So every single time you're going to start with y equals mx plus b. Alright, questions on the word? Alright, I'm going to throw one more thing in here. Let's say I had, for example, this graph. If it lets me. No.
Does anyone have this graph in the proof?
We will have to look at some graphs, which is why I'm throwing out your numbers. Let's say I asked you what's the equation for this line. Alright, so again, y equals mx plus b. Find your slope. How do I find my slope, Louise? Rise over run. So let's pick two very nice points that intersect perfectly.
That one.
This one? Or this one? This one. Alright. So, how much do I go up? Good. And how much do I go over? And this is the positive or negative slope?
Negative.
Negative, right? We're going down as we go to the right? Okay, what's negative 4 over 2? Very good, negative 2. So this is my slope, right? Okay, we have that. What's the other piece I need? The y-intercept. What's my y-intercept? Negative 3. Oh, look, these are the easy ones, because all we have to do now is write our equation. And we're done. Not that bad, right?
Plus negative 3, that's okay. You can totally press it out.
The x? This x right here?
Mm-hmm.
So this is my equation for a line. M represents my slope, B represents my y-intercept, and then x and y are every single point along here. So like this point here, x would be 1 and y would be negative 5. This point here, x is 0, y is negative 3. This point here, x is 2, y is negative 7. What's that?
So what's on? Until what's on?
Okay, questions on this? Alright, so we're ready for the quiz. We feel good?
Let me see one more time.
We'll go over homework first, but just want to make sure we're feeling good. Okay, so worksheet 8 here. Today what we're talking about is a line of best fit. Has anyone heard of that before, line of best fit? Know what we're talking about? A little bit. So remember back when we learned about scatter plots?
No.
A graph where we have a bunch of dots on it?
Yep.
We talked about the correlation, whether it was a positive correlation or negative correlation. The line of best fit is where we take those dots and we find the line that works best with those dots, that has the best fit of going through those dots. So line of best fit is the best possible line you can draw through those dots. Now be careful, we're not just connecting dots, we're drawing a line through it to approximate the relationship there. Alright, so linear equations are often used to model real life data. A lot of stuff we have for in real life, they use statistics and analyze the relationships between them. That's where I have linear equations. Today we will investigate some of these relationships. Alright, so as we discussed in Unit 3, a correlation is a relationship between two quantities. So it's how they affect one another. So we should all be writing this down in our notes. Crystal. The correlation represents the type of slope the scatter plot would have if it was a line. So if it's a positive correlation, that means a positive slope. If it's a negative correlation, a negative slope. Alright, so the correlation determines what type of slope we'll have for that. Alright, our first graph. What type of correlation is this? Positive, negative, or neither? Right, because if we were to draw a line through these points, it's increasing as we go to the right, so it's a positive correlation. Alright, how about the second one? Negative.
Isn't that like correlation?
What'd you say?
No correlation. No correlation.
Yeah, the last one is no correlation. Eight.
No, 10.
Can I have the next suggestion?
No, stay with
Now you're suggesting.
Okay, so let's talk about real life examples where we might see a positive correlation, a negative correlation, or no correlation. What's that? Rocket science. Alright, so positive correlation means that both values go up. As one goes up, the other goes up. As one goes down, the other goes down is a negative correlation. And no correlation means there's no pattern. So anybody have an idea what would be an example of a positive correlation? Yes, it's, we want that it's going to be increasing. But like, let's say for example, your age compared to how tall you are. For a certain extent, the older you get, the taller you get.
No.
How about another one?
You don't understand. You don't understand. You start off at the bottom, not many people are going on the new. So you can calculate how many people are starting to see that.
Yeah. That's some good lemonade that Jordy made. Yeah, so a lemonade stand. The number of days you've owned your lemonade stand or had your lemonade stand compared to how much money you've made. The longer you've been open, the more money you make. Good. Other ideas? Maybe the more sleep you get, the more awake you are in Algebra 1-7 period.
No, it's
More
not.
energy.
It's not how awake you are, it's more energy you get with it.
Alright, so let's go with the lemonade stand one. So let's say length business has been open. Versus the profit, the amount of money you've made. The longer you've been open, the more profit you make. Alright, how about a negative correlation? As one goes down, the other one goes down. Virginia?
Yes, you said. Yes, you
Yeah, so maybe like productivity, the less productive you are, the less you get done, or the less happy you are because you have more to do the next day. Good. Any other ideas, Jordan?
Electrical bill, more electricity used over time, the more money I can pay.
So that's true, but that actually be a positive correlation. Notice how you said more and more. So the more electricity increases, the price also increases. That's another good idea or a good example for a positive correlation.
And I should say, we also should specify, guys, it's not always just up or down, it's that they're going in different directions. If I said the less homework I do, the worse my grade is, that's still called a positive correlation. Because as one's going down, the other's going down. They're going the same direction.
Yeah, I think I've flip-flopped that. For negative correlation, as one increases, the other decreases. I think they supposed to decrease.
Either way,
As one increases, the other decreases.
just remember that with the positive correlation, it's not necessarily that they're both going up, it's that they're both going the same direction. They could both be going down.
Yeah.
Yes.
So, then more electricity used, less money.
Yes, good. So the more electricity used, the less money you have, right? As you use more electricity, the amount in your bank account goes down. Very good. That's one I usually like to use is debt. The more credit cards you have, or the more you purchase, the more Black Friday shopping you do, the less money you have in your bank account, right? Good, so let's go ahead and use that one. I like the electricity one. More electricity, less money in the bank. Good. All right, then how about no correlation? Two things that don't affect each other. That would be a no correlation.
That's hard.
This is a little bit harder. Let me give you an example. How about? Okay.
If say if something happens, there's gonna be no effect to it.
So what would be an example then? Give me an example.
I'm waiting.
How about this? You like basketball. How about the number of pages you read in a book versus how many points you score in a basketball game? Does this have a correlation? Doesn't really impact one another, right? So there's one. The number of pages you read in your... What do you have to read in English right now? You're not reading anything in English? Romeo and Juliet. The more pages you read of Romeo and Juliet, does that impact your basketball shooting percentage? No. Jordy, how about that?
The more lemonade you sell, the less ice cream you have.
Right, lemonade versus how much ice cream you have. The more lemonade you sell versus how much ice cream you have in your freezer. Probably doesn't impact each other. Alright, so that would be no correlation. So let's go with, how about this? We'll combine the two. The amount of lemonade sold. Limonada. Limonada. There's a tilde here.
Yes.
Is that right? Amount of limonada versus how many points you score in basketball.
So if you shoot a 3-pointer, then you guys don't drink 3.
No.
Then you have to drink 3 cups of lemonade.
Who does that?
Don't like it. Okay. All right. Number of points scored in b-ball basketball. All right, so let's go and move a little bit quicker through this part here. So when we have our scatter plot here, we can draw what is called a line of best fit. The line of best fit is simply a straight line we draw going through our scatter plot that most closely mimics the relationship here. So I want to make sure my line is as close to the pattern as possible. So if I were to draw that line, does that mimic the pattern super well?
No.
A little bit, it's positive, but wouldn't it be much better if my line was like this? Right? So what we're doing is drawing a line that is close to the pattern that we have here. Let me erase these so it doesn't mess this up. Alright. So we sketch the line that comes as close to the pattern as possible. We then find our slope, which is m, and our y-intercept, which is b, and write an equation in slope-intercept form, which is y equals mx plus b. So again, this is slope, this is y-intercept, and this is slope-intercept form. Then we can use this line to make a prediction. Because when I look at my graph right now, if I asked you at 4 hours of studying, what's the score? Well, when we go to 4, there's no dot, right? We don't know. But after we draw the line, then we can approximate about how much it is. So that's what's helpful for the line of best fit. Take data that we do have, find out the relationship, and make a good guess as to what it might be.
It's going. Well, if it has no correlation, you can't really tell.
Right, if it has no correlation, then we can't really tell. So we have to use for something that does have correlation. Okay, so the first one says we use the line best, what is the line of best fit for this graph? So anytime you're drawing your line of best fit, you need to use a straight edge. So use the back of your calculator. I'm going to pull up a straight line here. And we want to do our best to mimic of the relationship. Your finger doesn't work super well. Okay. So let's see. I'm gonna go. Approximately. What? That's not what I wanted. Approximately something like this. Now your line might be a little bit different than the person's next to you because there's no perfect, well, there is a perfect answer, but we have to use your calculators or some math by hand to find the perfect answer. But when we're sketching it, you just want to get a good approximation. So I'm going to go right about here.
Why
Yeah.
do you have the ability to do it with calculator? You chose to do it with calculator, not by hand. One that you do by hand is what would say sketch it by hand.
Something I like to do too, I remember when I was taught this, I like to have about the same number of points above my line as below. I have 1, 2, 3, 4 above, 1, 2, 3, 4 below. And notice that my line is pretty close to these. It falls right in between that. So again, yours might be here, might be a little bit higher, a little bit lower, but something around here. Right. Okay, so let's figure out what our equation is. Now, this starts to get a little bit more difficult because we don't have exact values. To find our line of best fit, we have to have, to write our equation, we need to have our slope and we need to have our y-intercept, right? Well, for this line that I chose, what does my y-intercept look to be? A little bit above 40, right? It's not quite on 40, it's a little bit above. I'd probably get, it's not quite halfway. 45 would be halfway, so maybe like 42, 41. And again, that's why your equation might be a little bit different, but as long as it's close to it. So my y-intercept, we'll say 41. Okay. Now for your slope, again, we want to pick two nice points. You're not always going to have perfect points there, but you need to pick 2 points and do your slope and your equation for slope. So remember your equation for slope is y2 minus y1 over x2 minus x1. Now, I actually did have my line go through 2 nice points here. So again, your slope might be a little bit different based upon your line. I could have also picked, like this point right here is probably about 4.75, so you could have used that as a point. Or this point here is about 3.67. So your slope might vary a little bit, but it'll be close to this. All right, so I'm going to use these 2 points here. How much do I go up? 5, right? 5 blocks. But look at our y-axis. Each of these is worth 10, right? So I went up 10, 20, 30, 40, 50. So I actually went up 50. So I went up 50. And then we go over 1, 2, 3, 4, 5, 6. Oh, these are going by ones, aren't they?
That's 7. Well, let's go.
It goes from 1 to 7, yeah. So I went over 6. So that's the tricky thing with this. Just look at your scale. I went up 10, 20, 30, 40, 50. Number 1, 2, 3, 4, 5, 6. Again, you could just actually write these points. If I write out what these points are, I have the point 150. And my other point was 7/100. And then you can just do your equation for slope. 100 minus 50 and 7 minus 1, which gives you 50 over 6. Okay. If you put this in your calculator, 50 over 6, what does that reduce down to?
Decimal.
What is it in a fraction of? Hit math fraction. Oh, I'm so
23, 25.
Good, 25 thirds. And Jordy, what was the decimal for that?
Hold on. I gotta clear it up. 8.350 continuing.
Okay.
I'll put a line on it. Shows it continuing.
That's true. Alright, so our slope is 25/3 or 8.3 repeating. X plus B. And my B value was 41.
And how'd you get that 41?
I looked at my y-intercept. It's a little bit above 40, so we said about 41. You might have said 42. 43.
No, I don't know.
Okay.
It doesn't matter.
No, just as long as you're close to that. Okay, so then it says predict the score of a student that studies for 4 hours. So now I can go to 4.
75.
Right here's 4. And about how much is that?
75.
Good, probably about 75.
You can also plug that 4 into your equation.
Yeah. You can also take 4. This is your x value. Put it in for x, and you'll get about that same amount. All right, questions on this? Okay. So on the back side, you'll see.
Wait, what did you put next to the 4 hours? 0.
What do you guys think? So you can take 4 and put it in for
About
x.
not getting the 5/10. If you didn't catch it, I missed that too. On our top first.
Okay, so you'll see 1 and 2 are similar things. Let's do 1 together. All right, number 1 says which equation best represents the data shown on the scatter plot. All right, so again, get out your straight edge and draw your best fit line through there. Give it your best shot. I'm going to draw mine up here as well.
No, that's all the squares.
So, Julie, what you want to do is draw a line that goes through the dots nicely. You don't have to connect each dot, but draw a line that goes through it. Okay. Again, it doesn't have to be perfect. We're trying to get an idea of what this looks like. So now, to choose our equation, let's take a look. We need to know slope, and we need to know our y-intercept. Well, first of all, is this a positive or a negative slope?
That's a negative.
It's a negative. So which ones can we eliminate?
Negative.
And that
D,
is y equals x/2, not y
D,
equals
and B.
Oh, yeah, b is supposed to be y equals
Oh,
x/2. So we can eliminate?
B and D.
We can eliminate b, right? All right. Now let's take a look at our y-intercept. So again, we said slope should be negative. What's our y-intercept? Positive or negative or 0? What is it? My y-intercept. Looks like negative, right? So which one is that going to give us? Yeah. See? Not bad. Okay. So now we get to learn how to find this equation using our calculator. So everyone needs to have a calculator out and get ready. You might need a calculator. Anybody else? Okay, so I want everyone on your calculator to find the stat button.
It's that.
Oh, Miss Charlotte. I emailed Mr. Studak during the end of 5th grade and we downloaded it. It only took a few minutes, so we have to change it. Okay, on your calculator, find your stat button.
Where's that?
What?
You are having trouble finding it.
Yeah.
You're gonna ask the person next to you, and then if they can't find it either, raise your hand, I'll come help you. Okay?
We know it's there.
Start.
Start. Stat. That is going to be your favorite button for this, alright? Stat.
Oh, wait.
Now, in your notes, you'll see at the bottom here, gives you the step-by-step instructions of how to do what we're about to do. I'm going to go ahead and walk you through the first problem. So, go ahead and flip your page over, and we're going to do number 3 together. Your favorite time of day, Louise. Okay, calculators up. Let me... Alright, so what you want to first do is hit stat.
Enter, edit.
Then the next thing is you want edit, so hit enter. Now some of you might already have numbers in here. Let me do it real quick. Some of you might already have numbers in there. If you have numbers in, we want to get rid of this. Now this is very important. Do not hit delete to get rid of your list. Only use clear. So I want to clear my list. So you arrow up. And don't hit delete. Don't do that.
I just hit delete.
Your list will disappear forever.
I just deleted.
So we hit clear and then arrow down.
You can also hit clear and then enter.
Yeah, clear or enter. So don't use it. Delete gets rid of your list forever, and then I have to, or Miss Charlotte has to get it back for you. But the problem is in the middle of the SOL and in the middle of your test, we can't do that. We're not allowed to talk to you. So don't ever hit delete. If I see you getting close to that delete button, watch out.
Wait, so if you put an equation and then do what you do, and then you press delete to delete it.
So this, you don't ever use delete when you're in your list. You can use delete other times on your calculator, just don't use it in your list.
You
never know there was
What would happen? Show us.
You sure you want to see?
Yes, I want to see.
Okay.
I see if it explodes.
It almost explodes. It comes close to it. Okay, so this is what everyone does. They're like, delete. There's no more list one. And then they get crazy and they go, delete, 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 delete. And then you have no list left.
I have it like that.
And now it's blank.
I have it blank.
Oh, no, it's good. See how it says L at the top? That's good. See how I have no L's at the top? That's bad.
So what are you gonna do? You gonna put it?
Now I'm going to do my secret method of getting it back.
What? We need to see that.
No, I don't want you to know because then you'll be tempted.
Well, then what?
I'll search.
Exactly. No one can fix it yourself.
SOL.
Oh, well, then why can't we get
Okay, I'll show you now.
Thank you.
So you can do second
Uh-huh.
insert, which is delete, then second stat, then you arrow down to whichever one you need and hit enter. It's a long process
That
though.
is
and
I
then
forgot
arrow.
already.
See, you already forgot. So now I have to do this for every single one.
Yeah.
So don't do it. Don't
Okay.
hit delete
But when you go back to the calculator, you have to do that again. Every time you're
Wait,
gonna
what
use
if
every time.
what if you're highlighting selecting a number and not one of those things?
That's fine. So if I'm using one of my numbers, you can do that. But just do clear. Or I guess delete works.
I'm gonna be using the. I'm gonna be using the.
Crystal.
We're going to be using calculator for today's lesson. And then what'd you ask?
No, we're gonna be using it every day.
Yes, just about. Just about. We'll use it a lot. Okay, so let's do number 3 together. So we all have list 1. We hit clear. Alright, so now we take our X values and put them in. So X goes into list 1. Alright, so my X values, 1, hit enter. See how 1 appears.
Did you write one?
Wait.
I wrote L1. List 1. So your X values go in list 1. So what I just did was hit 1, enter. Then my next number is 2. So 2, enter. Next number, 3, enter.
We were gonna say something.
And then
4, enter. 5, enter. 6, enter.
this is gonna
We're
take
gonna
forever to
say
do
something
one.
about someone.
No, you get pretty fast at it. You have a question? Okay. Alright, so now we do the same thing with our Y's, but Y's go in list 2. List 2. Okay, so in list 2. 2, enter. 5, enter. Make sure you hit 5 again. We have duplicates here.
Make sure that each one.
5, enter. 8, enter. 11, enter. 12, enter.
What is L2?
Yeah.
L3, that's if you had another variable, you won't ever have to use that in here though. Nope, not even the number for 2. It's for more so like statistics. Okay, so notice my lists match. They're the same length. That's good. Take 2 seconds and double check to make sure your lists are the correct numbers. Otherwise, you're going to get the whole problem wrong.
Make like say
So-
circular sweat.
Yeah, go back through. 1, 2, 3, 4, 5, 6, 2, 5, 5, 8, 11, 12.
And that one will go.
Okay, so now, stick with me.
Yeah, we are.
I need all your attention. Okay, so next we go stat. See how it says calc? We want to arrow to the right. So it says calculate. And then we choose number 4, lin regression. That stands for linear. We're talking about a line. So number 4, or you can arrow down. Now, some of you do not get this screen. You just get lin reg ax plus b. That's fine. You just hit enter. Those of you that get this screen, hit enter until you get down to calculate and hit enter.
5.
Alright, so we should all end with this.
What is that?
I got that.
You will see it.
I got that.
I got it.
Good.
Is that
I
a
don't like this.
So this is our answer.
It is.
So it says A is 2.029 because we have to round. And B is 0.0067 because we have to round.
This is the part where I fail.
Okay? So my equation is y equals, what is A?
I don't know.
2.09?
No, 2.02. Oh yeah.
2.029 because 5 makes it round. X, because that comes next in my equation, plus B. And what's B?
0.66.
0, 6, and we have to round that.
Did you say B? Why did I hear B?
Because your calculator says AX plus B.
It was about to
It's
They gave you
A
A.
has MX plus B except A.
Now, miss,
That's it.
that's it.
That's it. You're done.
But I forgot everything.
Now, if it asks you to predict a value, then we take that and we put it in for X, right?
You guys know what that-
You do have homework. Let me pass out your homework to you.
It's not like a sign that
So your homework is worksheet 10.
Oh my god.
Okay, so same idea for number 4. Find our line of best fit. So let me pull my calculator over. Okay, so again, we need to go to Stat, our favorite button, Edit. Now I have to clear my lists. So arrow up, clear, arrow down, over, arrow up, clear, arrow down. My lists are cleared. Again, my X values go in list 1, and my Y values in list 2. So my X values, we have 1.1, 1.8, hit enter after every single number, 2.0, 2.6, 3.2, and 4.0. Alright, and then same thing for your Y values.
So they look kind of dirty. Your sports look like they need clean.
So my Y values, I have 5.0, 4.1, 4.1 again, make sure you get that repeat, 3.5, 2.8, and 2.1. So especially when you have decimals like this, double check to make sure you got the right numbers. Make sure your lists are the same length and that the numbers are right. 1.1, 1.8, 2, 2.6, 3.2, 4, 5, 4.1, 4.1, 3.5, 2.8. Alright, we have our list. So stat, calculate, arrow to the right. Again, linear regression is what we want here. Number 4. And if you have an old calculator, you just hit enter. The newer calculators, keep hitting enter until it says calculate. And here's our equation here. So y equals, my a value is negative 9.9898. So let's get round. So negative 0.9898. Let's round it to 0.99. Then my B value is 6.0252. 6.025. Okay, so we have our equation here, and that's all there is to it. Now let's take a look at the next one. Alright, the next ones are the same idea, but it says that we need to, well actually the first one here, which equation most closely represents the line of best fit for this data. These answer choices are actually incorrect. Apologize for that. So again, we do the same thing, where we put our information in X1, or we put our X's in L1, and our Y's in L2. Okay. And then let's take a look at the one next one, number 6. So number 6 is a little bit different in that it requires you to predict a value. Alright, it says using a line of best fit, which is closest to the length of time it should take Debbie's 6-year-old niece to run 1 lap. Again, our first column is X, our second column is Y. This is what goes in list 1, Y goes in list 2. So 6 years old, that's an X value. So what I'm going to do is take this and put it in for X of my equation. So I need to first put this into my calculator to get the equation. So again, stat, edit, clear my lists, clear, clear again, down, type in my X value, so 4, 8, 10, 11, 14, 14 again, and 18. My Y value is 225, 185, 138, 130, 112, 106, and 52. Now let me double check my lists here. And I think they look good. Alright, so again, stat, calculate, linear regression, option 4, and enter until you get your equation. Alright, so my equation is y equals negative 12.125 x. This is my A value. And I have x plus b. My b value is 272.271. Alright, so again, to predict how long it's going to take Debbie's 6-year-old niece to run that lap, I take 6 and I put that in for x. 6 years old, that's my x, age of child years, so I put that in for x. So if we get, so I have negative 12.125 times x, and x is 6, plus 272.271. And I get 199.521, and that's closest to letter A, 200 seconds. Alright, so again, my answer on my calculator was 199.521. That was my Y value, and that's closest to 200 seconds. Alright, now let's take a look at number 7. Alright, we'll do 7 and then we'll call it good. So that's another prediction one. So anytime you're predicting, you have to find your line of best fit and then take that and put it in. Alright, so again, we have our X values and Y values. If it helps you out to write a list, go ahead and do that. My X values are 2, 3, 5, 10, 12, 15. Put that in my calculator. Stat, edit. Again, clear my list, do not delete them. So my X values were 2, 3, 5, 10, 12, and 15. Alright, and then my Y values, 16, 15, 13, 11, 10, 11. 16. Make sure you go in the same order. 15, 13, 11, and another 11. Alright, so now calculator line the best fit. So stat, calculate, option 4. Keep hitting enter till you get your equation of, here we go, write out our equation. So y equals, my a value is negative 0.420x plus my b value, which is 15.957. Alright, close enough. Alright, so then I take, it says, what is the prediction when the input is 15? So that input is my x value. So I take 15 and put it in for x. So my equation, I have negative 0.42 times x, which is 15, plus 15.957. Give me an answer of 9.657, which is closest to 10. So again, line of best fit, stat button is what you want to use. Then to make a prediction, you take that equation and take the value and put in for x. Remember, worksheet 11 is your homework. We will have a mini quiz on this next class. Make sure you come see us if you have questions.